Hello everyone. Now from today I am going to start the acid base salt of class 10 ICSE, and it is very important chapter for ICSE students. Okay, and along with the other classes will be going on. Already videos are started to upload. So today I will start the acid base salt of class 10 ICSE. Okay, so today normally we'll discuss the basic concept of acid and base. Basic concept of acid and base. That means what is acid, what is base. Okay, that one we will discuss. First of all, what are the acids? According to Arrhenius, one scientist was there whose name is Arrhenius. Okay, he has given the idea of acid and base first, and that is called Arrhenius acid base theory. Arrhenius acid base theory. Now that theory we will discuss first. Okay. Now, according to him, acids are the substances which will release H plus, that is hydrogen ion, or hydroxynium ion, that is H2 plus ion in aqueous solution, are called acids. That means the substances which give H plus or H3 plus ions in aqueous solutions are called acids. Okay, so we can say that those substances which have H in their formula, they will give H plus ion in aqueous solution. Okay, that means they will ionize. Okay, that means they will ionize to form H plus and Cl minus, like that. So normally those substances which have H in their structure or formula, they will give H plus, and they will be called as acid. Okay, so what is the definition of acid? The substances which will release or dissociate to form, H plus or H3O plus. This H3O plus is called hydroxynium. Okay, H3O plus ion in aqueous solution. Are called acids. Now this will be called as Arrhenius acid. Okay, because according to the definition, those will be acids which will give H plus or H3 plus in aqueous solution. Now we will take some example. Okay, say HCl. Now the compound HCl is called hydrogen chloride. This compound is called hydrogen chloride, and it is a covalent compound. Now hydrogen chloride will be called in gaseous state, but when this compound is in liquid state, that means in aqueous solution, it will be called as hydrochloric acid. This compound will be called as in liquid state, it will be called as hydrochloric acid. Okay, hydrochloric acid. Okay, now why it is acid? According to Arrhenius, as it will furnish H plus ion in aqueous solution, that's why it is an acid. Okay, so let's see. HCl. If we add HCl in water, it will furnish H plus and Cl minus. That means the HCl solution, say in a beaker, HCl is there. That means hydrochloric acid is kept in a beaker or in a jar. That means what are the ions are there? It is in the H plus and Cl minus form, not in completely HCl form. So hydrochloric acid means H plus and Cl minus. Okay, and as it is forming H plus, that's why it is an acid. Okay. Now this is the ionization of HCl actually. Ionization of HCl. This is called hydrochloric acid. Okay. Now another acid, H2SO4. Okay, H2SO4 in aqueous solution furnishes, that means it is a compound. First of all, it is a compound. Now it will form here HCl forming 1H plus because 1 hydrogen is here. Now here 2 hydrogen you can see, so it will form 2H plus. That means 2H plus SO4 2 minus. SO4 will be 2 minus because overall there will be no charge. Okay, that means charge will be neutralized. So 2 plus 2 minus is neutralized. Okay, so here H2SO4 means 2H plus SO4 2 minus. Okay, this is the dissociation of H2SO4. This compound is called, that means this acid actually is called sulfuric acid. Okay, we have heard the name sulfuric acid. Now number 3, nitric acid. This is called nitric acid, HN3. Okay, it will form H plus and NO3 minus. And these all are called inorganic acids. These all are called inorganic acids. Now normally this HCl is called muriatic acid. Okay, because HCl we are using in our daily life to clean the washrooms like that. So it is muriatic acid. Okay. Nitric acid is called aqua fortis. Aqua fortis. Another name of nitric acid is called aqua fortis. Okay. So this one we can keep in mind that nitric acid is aqua fortis and HCl is muriatic acid. Okay, muriatic acid. Okay. Done. Now first of all I am telling about the acid, then after I am going to the bases. Now how these acids are dissociating in aqueous solution, on the basis of that acid can be classified. On the basis of that how it is dissociating to form H plus, on the basis of that acid can be classified. Okay, so acids are actually two types. One is called strong acid, one type is strong acid, another type is weak acid. Opposite of strong is weak acid. Okay, now what are the strong acid? It means the concentration of the solution will be higher. That is the strong acid. Okay, and we can see the definition of strong acid, that acids which are dissociates completely in aqueous solution. Acids which are dissociates completely in aqueous solution, that means it is forming complete ions. Molecule will not be there. Completely dissociate in complete ions. Complete separation will be there. That is called strong acid. So acids which will dissociate completely in aqueous solution to form complete ions are called strong acids. Now the previous acids which I have already shown you, all are strong acids like HCl. Okay, example HCl, H2SO4, HNO3. These all are strong acids because this will furnish completely ions. That means this will ionize totally, fully ionized state. Okay, done. Now weak acid means the acids which are not completely dissociate in aqueous solution, which will partially dissociate in aqueous solution, are called weak acids. Okay, so they will partially dissociate. Examples are CH3COOH. Okay, this one is an organic acid. We will learn in organic chemistry. CH3COOH, organic acid. This is called acetic acid. Why organic acid? Because of this group COOH. Okay, we learned this one in organic chemistry, that this COOH group is called carboxyl acid group. Carboxyl acid group, one of the weak acid. Okay, next HCOOH. It is also a weak acid and name is formic acid. Okay, so these are the example of weak acid and strong acid. Now what is the main characteristics of strong acid? Complete dissociation. In aqueous solution. It will remain as complete dissociation state in aqueous solution. Okay. Partial dissociation. Dissociation in aqueous solution. So these are the two main difference between this strong acid and weak acid. Complete dissociation, partial dissociation. Okay. Now we will see how this will dissociate actually. Now why I am telling this HCl is strong acid or complete dissociation? Because see HCl, it will not be present in a solution in compound state, that means in HCl state. We cannot say that HCl is there. Okay, in solution it will be remain as H plus and Cl minus. Only H plus and Cl minus ions will be there, not total HCl molecule. Okay, that's why it is strong. But CH3COOH, which is weak acid, this is strong acid. This compound is strong. But CH3COOH will furnish CH3COO minus ion. First of all, this H plus will be released. Okay? Because this COOH group is called carboxyl group, which is organic functional group. Now there, this H plus is the responsible for the acidity. So first of all, this H plus will be released in case of weak acid. That means this will release as positive charge, and the other part will be remain as negative charge. Okay, so CH3COO minus H plus. Now here you can see again that again this hydrogen will not dissociate. Okay, it is first of all it is dissociated to form CH3COO minus and H plus. After that, this hydrogen will not dissociate. Okay, this will not furnish any kind of H plus. So this will remain as an undissociated form. This is called acetic acid. Acetic acid. This is called acetate ion. And this is hydrogen. Now what I am telling that this acetate ion will not dissociate again. It means partial dissociation. It means partial dissociation. It means partial dissociation. Now, whenever examiner asks you, say in laboratory, one beaker of acetic acid is there, and it is written there acetic acid solution. It is written there acetic acid solution. Now, examiner is asking you, tell me what are the compounds are there, what are the ions are there. You have to say that in this solution, first of all, CH3COO minus ions are there. That means acetate ions are there. Again, H plus ions are there, and also CH3COOH is also there. Okay, because it is partial dissociation. This CH3COOH is not fully dissociated to form in the ions, so the molecule will be also there. Okay, so it is kind of equilibrium. Acetate ion will be there, H plus ion will be there, and also acetic acid molecule will be there. Okay, it is kind of equilibrium. When in the weak acid solution of a weak acid will be remain as a equilibrium. Okay, so these are the important things you have to learn about the acids. Okay, done. Now bases. Okay, base. Base means Arrhenius told according to the Arrhenius concept. Whatever I am telling here according to the Arrhenius concept. Okay, Arrhenius concept of base. Arrhenius concept of base. Here, what he is telling that bases are the substances which will dissociate to form OH minus ion in aqueous solution. Okay, OH minus means hydroxyl ion. Okay, so this will furnish OH minus ion, which is called hydroxyl. Okay, so I am writing just the definition. The substances which will dissociate to form OH minus, that means hydroxyl ion in aqueous solution are called bases. Okay. Now the compound which will have OH in the formula, that will furnish OH minus. Otherwise it can't. Okay. So examples are sodium hydroxide, and the name of the base will be ended with hydroxide if it has OH. If the base has OH, it will be named as hydroxide. Sodium, name of the metal, and after that hydroxide, like NaOH. In NaOH, Na is the metal, so sodium, and end with hydroxide, sodium hydroxide. Okay. Potassium hydroxide, potassium hydroxide, KOH. Okay. Calcium hydroxide, that is CaOH whole 2. It is the formula of calcium hydroxide, CaOH whole 2. Okay. Metal with hydroxide. Okay. And mostly these are alkali and alkaline earth metals. Okay. Will be the bases. Now let's see the ionization form of these bases. Say NaOH. Okay. NaOH is here. So NaOH in aqueous solution will dissociate to form Na plus OH minus ion. Okay. This metal, as it is electropositive, so it will form a positive ion, and this oxygen is electronegative, so it will form a negative ion. So as it is forming OH minus, so it is, according to the concept of Arrhenius, it is base. Okay. So this is the dissociation of sodium hydroxide. Okay. Sodium hydroxide. Now potassium hydroxide, KOH. Okay. It will form K plus and OH minus. Calcium hydroxide, CaOH whole 2. It will form Ca2 plus 2OH minus. Calcium hydroxide, Ca2 plus 2OH minus. Okay. So it is, as it is totally electrically neutral, 2 OH are here, so 2 OH minus, and it will form bivalent ion, this calcium, so calcium 2 plus. Okay. These are the bases. Aluminium hydroxide, AlOH whole 3. What you will do? This will form the charge of the cation, aluminium 3 plus. This will go here, see. Okay. And same number of OH minus ion. The charge of the cation will be same number of OH minus ion. That is aluminium hydroxide, COH minus. Ferric hydroxide, FeOH whole 3. Ferric ion, Fe plus 3. This will go up, Fe plus 3 and 3OH minus. Okay. So these are the dissociation form of some bases. Okay. Note it down. Okay. Now I'm erasing. Okay. Now, same as acids, bases can be classified. How it is dissociating in aqueous solution? Completely or partially? Like strong base and weak base. Okay. Strong bases are, partial dissociation will be there for strong base. Partial dissociation for weak base, for weak base partial dissociation, and for strong base complete dissociation. Complete dissociation. Like KOH, NaOH, these are strong bases, and ammonium hydroxide is an example of weak base. Ammonium hydroxide. Okay, so these examples are important. Now another common phenomena is there, that means we are using in chemistry the term alkali. The term alkali, same thing, it is somehow related to the base. Okay. What is the difference between alkali and base? normally all the bases which are formed by alkali and alkaline earth metals like sodium hydroxide, potassium hydroxide, these are bases. Calcium hydroxide also is a base, and again ferric hydroxide also a base, aluminum hydroxide also a base. These are formed by transition elements. These are formed by transition elements. Why? Because iron and aluminium both are transition element. So this iron is transition element and aluminium is from P block. Okay, so they are not actually the alkali and alkaline earth metals. This sodium, potassium are alkali metals. That means in P block, in periodic table, they are in group number 1. So sodium, potassium are alkali metals and calcium, alkaline earth metals. Okay, so these are the bases of alkali and alkaline earth metals. We have seen that these bases can easily dissolve in aqueous solution. These all are bases. But out of these 5, what I have written here, only the top 3 can easily dissolve in aqueous solution to form what it forms, Na plus and OH minus. Totally dissolved. No undissolved form will not be there. Totally dissolves. Okay, dissolved in aqueous solution. Dissolved in aqueous solution. Okay, but iron hydroxide, that means ferric hydroxide and aluminum hydroxide, will not dissolve in water. Will not dissolve in water. So though these all are bases, but some difference are there between these 3 bases and these 2 bases. The bases which are completely dissolved in aqueous solution, they are called alkalis. That means these 3 are called alkali, and these are normal bases. These are normal bases, these 2, iron oxide and ferric hydroxide and aluminum hydroxide. So we can say that all the bases are not alkali, but all alkalis are bases. All the bases are not alkali. Those bases are alkali which will dissolve in aqueous solution. Okay, but all the bases are not alkali because these iron hydroxide and aluminum hydroxide are not alkali. Okay, so this thought comes actually explain all the bases. All the alkalis are bases, but all the bases are not alkali. Okay, so these kind of questions are coming actually. Okay, so today is up to this on this acid base theory. Next day I will discuss over on this acid base theory from indicators, neutralization reaction, preparation or how we can identify these acids or bases. That one we will discuss. Okay, and simultaneously the other classes video will be uploaded. Okay, so thank you for today's video. Okay, and if you like this video, then do like, comment and share.